In today's video, I'm going to explain derivatives simply, and trust me, it might sound a little bit too fancy, but it's easier than you thought. So let's get started. Let's say you're walking in a street or something, and you keep track of how far you go by each second. So after 1 second, you covered 2 meters. After 2 seconds, you covered 2 more meters. For the third second, you covered 2 more meters. That's the sum of 6 meters in 3 seconds. You can just get the speed by dividing the distance over the time, which is 6 divided by 3 equals 2 meters per second. And that's the speed. What about the derivative? A derivative is like finding how fast you're going based on how your distance is changing over time. Let's look at something simple. Let's say we have this equation, which is y equals x squared. This means if you pick any value for x, let's say 1, 2, and 3, here y is going to be x squared, which is 1 squared equals 1. In this case, it's 4, and in this case, it's going to be 3 squared, which is 9, right? But now we want to know how y is changing as x gets bigger. That's where we use the derivative, or d over dx. The derivative for x squared is 2x. But what does that mean? So what do I mean when I say that the derivative equals 2x for this equation? Let's say when I have x equals 1, the rate of change according to this derivative is 2 multiplied by 1 equals 2, right? So this means at x equals 1, for every 1 unit you increase in x, y increases by 2 units. When x equals 2, the rate of change according to this derivative is 2 multiplied by 2 equals 4. And that says that y increases by 4 units for every 1 unit you increase in x. So how do you get the derivative from an equation? That's what we are going to figure out right now. Let's say we have this equation, y equals x squared. In order to get a derivative for any equation, you have to follow this law, which is nx raised to the power of n minus 1. And n is the power of x. So in that case, 2 is the n. So the derivative for x squared, we're going to get this power beside it, which is going to be 2x. And in the power, we are going to do 2 minus 1. It's equal to 2x power 1, which is 2x. What about this one? You're basically going to take this power, place it beside it, so it's 4x. And for the power, you're going to subtract 1 from the main power. So it's 4 minus 1. So it's 4x power 3. Let's see one more example. Derivative for x power 7. Take this power, place it next to the x. So it's going to be 7 to the power of 7x. And now for the power, you're going to subtract 1 from this number or the main power. So it's 7 minus 1. So the answer is 7x raised to the power of 6. Now you gotta know is that derivative for any constant or any just number, let's say 3, is always equal to 0. Derivative for 8 is 0. And the derivative of 1 million is also 0. What about the derivative of this? 3x. What is the derivative at this point? So you have to know that x has a power of 1, that you don't really have to put it, right? So we're going to do the same thing right here. Take the power, place it beside the x. But there is a constant right here, right? So we're gonna just keep it for now. Just write it and leave it. And do the same thing you're always doing. The 1 beside the x, raised to the square of 1, which is the main power, minus 1. So you have 3 multiplied by 1, x to the power 0, and you know that's anything raised to the power of 0 equals 1. So the answer is 3 multiplied by 1 equals 3. Let's see one more example. What about the derivative for 4x raised to the power of 2? There is a coefficient here. We're just going to keep it, open some brackets, and do the same thing we're always doing. Get the power beside the x, so it's 2x. And for the power, you're going to subtract 1 from the main power, which is 2. So 2 minus 1. So you have 4 multiplied by 2x to the power of 1. And that equals to 4 multiplied by 2 of x. So it equals to 8x. Alright, so now this question is for you. What is the derivative of 3 multiplied by x squared raised to the power of 3? Pause the video and try to solve it. So firstly, we're going to multiply the powers here and here. So it's going to be 3 multiplied by x to the power of 2 multiplied by 3. So it's 3x to the power of 6. Now in order to get the derivative of this, we're keeping this coefficient as it is. Open two brackets, take this power, place it beside the x, so it's 6x. Subtract 1 from the main power, which is 6. So it's 3 multiplied by 6x power 5. Just multiply 3 and 6. So it equals to 18x to the power 5. So what about this question? 1 divided by x to the power of 3. You know that 1 divided by x equals to x power of negative 1, right? So in that case, 1 divided by x to the power of 3 equals x to the power of negative 3. And to get the derivative for x raised to the power of negative 3, you get this power, place it beside the x, so it's negative 3x. And for the power, you subtract 1 from the main one which is negative 3, so it's negative 3 minus 1. So the derivative for 1 divided by x to the power of 3 is negative 3x to the power of negative 4. You can also put this into the simplest form, so the final answer is going to be negative 3 divided by x to the power of 4. Let's see this idea. Find the derivative for this one. Negative 2 divided by x cubed. So you know that this one is just the simplified version from negative 2x raised to the power of negative 3, right? So here you have a coefficient of negative 2. We're going to just keep it, x to the power of negative 3. So get the derivative as you're used to it here. Take this power, put it beside the x, so it's negative 2 multiplied by negative 3x, and for the power, you just subtract 1 from the main power. So it equals to negative 2 multiplied by negative 3x power negative 4. Look to multiply this by negative 3. So the final answer is going to be 6x raised to the power of negative 4. And just simplify it for the simplest form. It's going to be 6 divided by x to the power of 4. What about this one? What is the derivative of the square root of x? Firstly, you have to note that the exponent here is 1 and the index number is 2. And as you know, if any number is raised to the power of a fraction, let's say the power of half, the numerator is the exponent and the denominator is the index number, right? Let's say x raised to the power of third equals to the cubic root of x to the power 1. X power half equals square root of x to the power 1. So we just need to rewrite this. So it's going to be derivative of x to the power half. And you are just going to repeat the same process. Grab this power beside the x, so it's going to be half x raised to the power of half minus 1. It's going to be half x to the power of negative half. And you have to note that this is equivalent to saying that x the power of negative half over 2. And since you just have a negative power here in the numerator, we're just going to grab this x down to the denominator with its power. So it's going to be 1 divided by 2x to the power of half. And as we said earlier, x to the power of half equals to square root of 2, square root of x I mean. So it's 1 divided by 2 multiplied by the square root of x. So this is the final answer. Alright, so let's see this question. What is the derivative for cubic root of x to the power of 4? Feel free to pause the video and try to solve it yourself. So as you know, this is the exponent, this is the index. We're going to rewrite this. So it's going to be what is the derivative for x raised to the power of 4 divided by 3. You're going to repeat the same process. Grab this power right here. It's going to be 4 over 3 x raised to the power of 4 over 3 minus 1. So it's going to be 4 over 3 x to the power of 1 over 3. This is the index, and this is the exponent. So in order to rewrite this, it's going to be 4 over 3 cubic root of x power 1. So the final answer is going to be 4 multiplied by the cubic root of x divided by 3. Let's see another question. What is the derivative of this? Pause the video and try to solve it yourself. So as you know, this is the exponent, this is the index. In order to rewrite this, it's going to be x to the power of 5 divided by 8, right? Going to take this, place it before the x. So it's going to be 5 divided by 8x raised to the power of 5 divided by 8 minus 1. So this is going to be 5 divided by 8x, the power of negative 3 over 8. So we are just going to rewrite this since we have a power with a negative. So it's going to be 5 over 8 multiplied by 1 over x to the power of 3 divided by 8. This is the index and this is the exponent. So it's going to be 5 divided by 8 multiplied by 1, x to the power of 3. So the final answer is going to be, multiply this, multiply that, going to be 5 divided by 8 x to the power of 3. This is the final answer. Alright, so now let's see the derivatives with the functions. So let's say we have a function of x equals x squared. You know that the derivative for x squared is 2x. So the derivative for this function, which is f prime of x, equals 2x. What about f of x equals 3 power 2? What is the f of prime of x? It's 0, because I said the derivative of any constant is always 0. What about f of x equals x to the power of 4? F prime of x equals 4x to the power of 3. Alright, so now let's see how to get the derivative of a function. Let's say 4x cubed plus 7x squared negative 3x plus 4. By the way, the notation for derivative of function is f prime of x. Alright, so yeah, how to get f prime of x? We are basically getting the derivative for each term separately. So let's get it. Derivative for 4x cubed plus the derivative for 7x to the power 2 minus the derivative of 3x plus the derivative of the number 4. Alright, so let's get this one. Here the coefficient, we're just gonna keep it for now. Open brackets, take this power, put it beside the x, to the power of 3 minus 1. We are done with this. So derivative of 7x squared, we're going to keep the coefficient as it is. Open brackets, take this power, multiply it by x, 2x to the power of 2 minus 1. And we're done with this. Minus, let's get the derivative for this one, which is going to be 3 multiplied by 1x to the power of 0. And you know the derivative for, and we're done with this, and derivative for any constant or any number is always 0. So this one is going to be 0. So the final answer is going to be, multiply 4 by 3, going to be 12x to the power of 2, plus multiply 7 by 2, so it's 14x to the power of 1, and this is going to be just 1, so it's going to be negative 3. And this is the final answer. This is the f prime of x. Alright, so let's see another question on how to get derivative of a function. Let's say 9x cubed plus 7x squared minus 4x plus 11. So f prime of x is, we're going to get derivative for each term separately. So it's going to be derivative of 9x cubed plus the derivative 7x squared minus the derivative for 4x plus the derivative of 11. So let's get this. We are going to use the power rule and just put the power right here beside x, but first you have a coefficient here. Just going to put it as it is. Open brackets, use the power rule, 3x to the power of 3 minus 1, and we are done with this. Plus, here the coefficient, we're just going to keep it, open brackets, 2 multiplied by x to the power of 2 minus 1. We are done with this. Minus derivative of this, which is 4 multiplied by 1, x to the power of 1 minus 1, and we're done with this. And you know that derivative for any number or any constant is 0, so plus 0. So we're going to multiply 9 by 3. It's going to be 27. 27 x to the power of 2 plus multiply 7 by 2. It's going to be 14 x to the power of 1. And you know that x to the power of 0 is 1. So negative 4 multiplied by 1 is negative 4. And the 0. So yeah, this is the final answer, or the derivative for this function, or the f prime of x. All right, so just let me tell you something real quick before I turn to the next topic, which is what is the difference between the tangent line and the secant line? Basically, the tangent line just touches the curve at only one point, like this one, while the secant line, it touches the curve at 2 points, this one and this one. And yeah, basically that's the difference. All right, so let's see this. You have a function of x equals x squared, and we wish to find the slope of the tangent line at x equals 2. So you know the derivative of this function. You know that f prime of x for x squared is 2x by the power o, right? So how to get the slope of the tangent line at x equals 2? Firstly, we need to evaluate this f prime of x with this number. So it's going to be f prime of 2 equals 2 multiplied by 2 equals 4. So on a graph, it's going to look something like this. Let me show you. At x equal 2, this is the tangent line. This is 2, and this is 4.